Good day everyone, this is I and Ida Guplo from Group 3 and I will be discussing to you about the standard deviation. The standard deviation. The standard deviation of a set numerical data makes use of the amount by which each individual data value deviates from the mean. The deviations, represented by x minus mean, are positive when the data value x is greater than the mean and are negative when x is less than the mean. The sum of all the deviations x minus mean is 0 for all sets of data. So let's proceed to the standard deviations for population mean, or rather population samples. If x sub 1, x sub 2, x sub 3, and so on is a population of n numbers with x mean of population, then the standard deviation of that population is population standard deviation square root of summation of mean minus populations squared over n is 1. If x sub 1, x sub 2, x sub 3, and so on is a sample of n numbers with a mean of x, then the standard deviation of the sample is mean square root of summation of mean minus sample squared over n minus 1 equals 2. So let's proceed to the procedure for computing a standard deviation. So the first one is, let us determine the mean of the n numbers. Second, for each number, calculate the deviation or the difference between the number and the mean of the numbers. The third procedure, let us calculate the square of each deviation and find the sum of these square deviations. The fourth one, if the data is a population, then divide the sum by n. If the data is a sample, then divide the sum by n minus 1. The fifth one, find the square root of the quotient in step number 4. So here is the example 1 to find the standard deviation. The following numbers were obtained by sampling a population. We have the data of 2, 4, 7, 12, and 15. Find the standard deviation of the sample. So take note, let us find the standard deviation of the sample. So here is the solutions. Step 1, the mean of the numbers is mean equals to sample equals 2 plus 4 plus 7 plus 12 plus 15 over 5. So our n is 5. So equals 40 over 5 equals 8. This is our mean number. Step 2, for each number, calculate the deviation between the number and the mean. So our x, we have 2, 4, 7, 12, and 15. So as what the step 2, x minus mean. So our mean is 8. So 2 minus 8 equals negative 6. 4 minus 8 equals negative 4. 7 minus 8 equals negative 1. 12 minus 8 equals 4. And 15 minus 8 equals 7. Our step 3 is calculate the square of each deviation in step 2 and find the sum of these square deviations. So let us copy the x, 2, 4, 7, 12, and 15. And in step 2, we have now the x minus mean equals negative 6, negative 4, negative 1, 4, and 7. So as what the step 3 said, let us square those square deviations. So negative 6 squared equals 36. Negative 4 squared equals 16. Negative 1 squared equals 1. 4 squared equals 16 and 7 squared equals 49. So we have the total of 118. And this is now our sum of the squared deviations. So in step 4, because we have a sample of n equals 5 values, then divide the sum 118 by n minus 1, which is 4. So 118 divided 4 equals 29.5. In step number 5, the standard deviation of the sample is sample equals 29.5 to the nearest 100. The standard deviation is sample equals 5.43. So let us take another example to know more about the standard deviation. So we have now the example number 2. A student has the following quiz scores: 5, 8, 16, 17, 18, and 20. Find the standard deviation for this population of the quiz scores. So we will get the population. So here the solution. Step number 1, we will add those data. Mean equals 5 plus 8 plus 16 plus 17 plus 18 plus 20 equals 84. So we have n of 6. So 84 divided by 6 equals 14. In step number 2, we have x our data, which is the 5, 8, 16, 17, 18, and 20. So x minus mean. So our mean is 14. So 5 minus 14 equals negative 9. 8 minus 14 equals negative 6. 16 minus 14 equals 2. 17 minus 14 equals 3. 18 minus 14 equals 4. 20 minus 14 equals 6. In step number 3, we will square those x minus mean. So negative 9 squared equals 81. Negative 6 squared equals 36. 2 squared equals 4. 3 squared equals 9. 4 squared equals 16. And 6 squared equals 36. So let us add these squared deviations and we will get the sum of 182. This will be our sum of the squared deviations. In step number 4, because our data is population, then divide the sum by n. So take note, our n is 6. 182, the sum of square deviations over divided by 6 equals 30.3. So in step number 5, we will get the square root of our population. So populations equals square root of 30.3 equals population equals 5.50. This will be the standard deviation of the population is population equals square root of 30.3 to the nearest 100. The standard deviation is population equals 5.50. So that's all for my part. Thank you.
So, good morning everyone. Today I will continue discussion about the standard deviation. By the way, I'm Giselle Aurelius. My topic is how to solve standard deviation. A consumer group has tested a sample of 8 size D batteries from each of the 3 companies. The result of the test are shown in the following table. According to this test, which company produces batteries for which the value representing hours of the constant use have the smallest standard deviation? So here's a table. The 3 companies, the Ever So Bright, Dependable, and the Bacon. So the mean for each sample of batteries is 7 hours. So since it was discussed in the previous slide to how to get the mean, so just follow to solve the mean. The batteries of Ever So Bright have a standard deviation of 1.328 hours. So just follow the step so that we will come up in 1.328 hours. The batteries from the expandable have the standard deviation of 0.719 hours, while the batteries from bacon have a standard deviation of 0.877 hours. So in the conclusion, the batteries from dependable have the smallest standard deviation. According to this result, the dependable company produces the most consistent batteries with regards to life expectancy under the constant use. So here is the another example to get the standard deviation. A consumer testing agency had tested the strength of 3 brands of each roof. The results of the test are shown in the following table. According to the sample test result, which company produces each roof of which the breaking point has the smallest standard deviation? So the 3 company is the Trustworthy, Brand X, and Never Snap. So we have to solve first the mean. So the mean of the 3 company is 130-inch roof. So how do we come up 130-inch roof? So we have to add all of the given value by each of the company. Examples in Trustworthy, we have to add all of the given value, then divided by the size number of the size number, then the result is 130. The roof of the Trustworthy have a standard deviation of 3.671 inch roof. So how do we come up 3.671 inch roof? So here is the table to further understand. So we have the given value, the mean, the variance, and the sum of the squared division. So since it was discussed in the previous slide, so it is easy for us to understand or to formulate to come up in 3.671 inch roof, the standard deviation. So the result of the sum of the square division is 1,752 divided by 130. So divided by the mean. So we have 13.47693230769. So we have to square root it so that we will come up in 3.671. So the standard deviation of the Trustworthy company. Next is the Brand X, the standard deviation of the Brand X. So just like in the previous slide, so just follow the step. So we have 4.861 inch roof. So here is the table. We have the given value, the mean, the variance, and the sum of the squared division. So after that, we have to the sum of the square division divided by the mean is equals 3072. So divided by the mean, which is 130, we have 23.6307692308. Then we have to square root it to come up with 4.8 4.821 inch roof. So after solving that, we come up in 4.861 inch roof, the standard deviation of the brand X company. So next is the Never Snap company, the standard deviation of the Never Snap company. So just follow the step. So the standard deviation of the Never Snap company is 2.134 inch roof. So here's the table to really understand. We have the given value, the mean, the variance, and the sum of the square division. So just like in the other example to getting the standard deviation, after adding, we have to divide it by the mean. So the standard deviation is 2.134 because the total of the sum of the square division is 592. So 592 divided by 130 is equals to 4.5538461538. So after that, we have to square root to find to get the 2.134 inch roof, the standard deviation of the Never Snap company. So the conclusion is the agency from the Never Snap have the smallest standard deviation, since the standard deviation of the Never Snap is only 2.134. According to this result, the Never Snap agency produces the 1/8 inch roof breaking point in pounds. So that's all for today, and thank you.
Hello everyone, this is Erica Malyoran, a Group 3 member, and for today I am going to discuss to you example 5 and 6. So we have here example number 5. Use a calculator to find the mean and standard deviation. So we have use a graphing calculator to find the mean and standard deviation of the times in the following table. Because the table contains all the winning times for this race up to the year 2012, the data set is a population. So we have here the data set. So Olympic women's 400 meter dash results in seconds. So we have 52 up to 49.55. So for this solution, we have on a TI-8384 calculator, press stat, and after that you need to enter, and then enter the above times into list or L1. So those data population, you need to input it on the list 1 or the L1. So press stat again and twice enter. So the calculator displays the mean and standard deviation shown below. Because we are working with the population, we are interested in the population standard deviation. So here is the answer. So for the mean, we have 49.4583 and so on. And for the sample standard deviation, we have 1.066598 and so on. And for the population standard deviation, we have 1.0211 and so on. So for you to understand or to know on how to use TI-8384 calculator in solving this, we have I am going to show you on example number 6 on how to use the calculator. So we have example number 6. Use a calculator to find the mean and standard deviation. Use graphing calculator to find the mean and the population standard deviation of the race times in the following table. So this is the data population. For the Olympic men's 400-meter dash results in seconds. So we have 49.4 up to 43.94, and we're going to solve it using the TI-8384 calculator. So here it goes. So this is the, okay, we'll go back and then, all right. So the first move is that we're going to press the stat, okay, stat, and then edit. I listed all the data population already. So from 49.4, as what I have shown a while ago, up to 43.94. So after inputting all the data, we need to press the stat. And then we're going to calculate. So we'll go with calc. So since we inputted in list 1, so we have 1 var stats number 1. And then after it, we need to press second. The color is blue. So here, second. And it puts 1 var stats. And after that, we need to press L1. As what you have seen in number 1, it has L1 upper. So we have L1. And then enter. So here is the answer for the data population of the Olympic men's 400-meter dash. So our mean is that 46.0918, and our sample standard deviation, we have 2.523, and our population standard deviation, we have 2.47, and so on. So we'll go back to the presentation. So here, the solution. For the first solution, we have listed all the data. We have here 49.4. And then for the second, we have the result. For the mean, 46.0918. And for the sample standard deviation, we have 2.523, and so on. And then for the population standard deviation, we have 2.4760, and so on. So in solving this one, we really need to have a calculator so that it would be easy to answer. So I hope you learned from my discussion, and that's all. Thank you.